All right, so today we're going to talk about section 2.4, which is surveys and cardinal numbers. And we're actually going to see some Venn diagrams again, but we're going to be looking at them from a very different perspective than we did before. Not only that, but we're going to be putting numbers in like we did last time, or there's going to be numbers like we had last time, but they're going to mean something different. So the first thing I want to talk about is the cardinal number formula. I'm going to show you what the formula is, and then with a Venn diagram, I'm going to show you why it makes sense. Okay? So the cardinal number formula says the following. The number of items in a union of two sets is the number of items in the first set plus the number of items in the second set minus the number of items in the intersection. So that's cardinality. That's the n of whatever. That's what we mean by cardinality, is the number of items. So let's imagine what this is talking about. So you know what the union is. If I were to shade the union, where on this picture is the union? All of the inside of the circles, right? So we'd have this piece, the overlapping piece, and this piece, right? Okay, so all these three pieces are the union. What I want to do is I want to shade each of these regions on the right-hand side of this formula. Okay, well, at least we'll start here. If I were to shade circle A, it would look something like this, right? That's all of circle A. I'm going to change colors, and now I'm going to shade all of circle B. So if I do that, what do you notice? I overlapped my shadings in the middle, right? So in other words, if I counted everything in circle A and I counted everything in circle B, I actually counted the middle twice, didn't I? And that's why this formula shows that we need to subtract however many was in the middle one time, because we double counted it when we did the first two pieces. Does that make sense? Okay, so we need to make sure we're not double counting is the issue. And I want to take a look at an example of that. Example number 2 applies to that directly. We're going to do example number 1, the Venn diagram first. And we have this picture. Now, here's something different about what's going on in these pictures. I don't know why I'm using it on the outside, but let me put it out there. These numbers before, when we've had numbers in there, we put them in and they just sort of represented the area of space we're talking about, right? They didn't really have any numerical value. They just sort of were a placeholder to talk about a space, right? Kind of like when you number people off in class. If I number you off 1, 2, 3, 4, I don't really mean like one's better than 2 or one's shorter than 2 or one's heavier than, I don't mean anything like that. I just gave you guys numbers. And that's what we did when we looked at the Venn diagrams last time. The Venn diagrams this time, those numbers in there are going to represent a number of items. So when you see a 3 over here, there's actually 3 items over here. So imagine putting the items in. I've got an A and a B and a C right here maybe. There's 3 items here. There are 6 items in the middle. And there are 2 items in the side over here on B. And then there are 7 items on the outside. Okay, so these numbers actually have a meaning now besides just sort of giving me a placeholder. All right, so the first thing this is wanting us to do is to take a look at these different areas and say how many items would be counted in that area. So the first one talks about A intersect B. So how many items are in A intersect B? 6. That's the overlap, right? That's pretty good from last time. How about A union B? Okay, so how did we get 11? That's correct. How did we get it? All right, so each of the inside of the circles added up. And we don't need that formula I just did a minute ago, right? Because I can actually see the numbers in each of the spaces individually, all parsed out, nice and neat, and I can add them. So this is actually 3 plus 6 plus 2. You do not have to write that down, but just so that everybody's clear where those numbers came from, that gives me 11. Now, what we're going to do on the last 3 parts is we're going to look at complements. So I want you to sort of put your thinking cap on how this is meaning. This says A prime or A complement. What does that mean? Outside of A. So the numbers outside of A are 2 and 7. And I want to know where that intersects B. And that's only in number 2. So when there's 2 circles, we can reason this out pretty well. Okay, I showed you how to do something with shading last time that was really nice for sort of moving into a 3-diagram example. But with 2 circles, we can work through the reasoning without that much work, right? Okay, same idea down here. I'm going to start with circle A. What numbers are inside of circle A? 3 and 6. And this says B complement. Would be 3 and 7. And where do those intersect? In 3. So this should be the values or all of the elements that are in circle A and not in circle B, right? Okay, we've got one more of them. Can somebody give me words, not numbers, but tell me in language, what does this E part mean? Okay, complement of A intersecting the complement of B, which means what in terms of my picture? Outside of A and outside of B, which is the number 7. You guys are doing fine. All right, so this is sort of how to interpret one of these diagrams. And this is great when the numbers are already given to you inside of a diagram, right? But sometimes you're given information like this to start with instead. You may or may not need to create a diagram depending on the directions, but sometimes the information starts out like this. So we're taking this sort of a piece at a time. All right, so this one says, make use of an appropriate formula, and we've really only had 2 formulas in this class. We had one formula that found numbers of subsets. Do you remember that one? 2 to the power of n and 2 to the power of n minus 1. And we've got this formula that we just did today, which was the cardinal number formula. Which one do you think it's referencing? The cardinal number formula. So I'm going to start out by writing that formula down. And it's kind of nice because this particular equation or information actually gives you all the information with A's and B's in it. So we don't even have to sort of change the letters we're considering. All right, so I know some of you are not big fans of algebra, and that is just fine. But this is much like algebra in the sense that when you're taking a look at these pieces, there are 4 pieces in this formula, right? There are 4 different components, and as long as you know 3 of them, you can find the 4th. Agreed? So if you write the formula down, you're just going to fill in the pieces of the formula that's given to you. So the first piece of or what it actually asks me to find in this particular question is it asks me to find the number of items in A union B, which happens to be on the left-hand side. But it wouldn't have to be, right? They could give me this piece and ask me to find this piece. And that'd be fine. We could do the addition. It's just addition and subtraction. We're not doing anything complicated with the values here. We just have to put them where they're supposed to go. So this is the piece on the left-hand side that I don't know. I don't know the number of items in the union. But I am told all 3 of the other pieces. I have to be, or I'm not going to be able to do the problem. So how many items are in A? How many items are in B? And how many items are in the intersection? And can we add 8 plus 14 minus 5? Sure. What do we get? 17. Do we agree? Excellent. All right, so we're going to piece some of this together. Some of the parts from the first example and some of the parts from that formula kind of idea with a lot of information. Isn't this lovely? Look at all those details you were given. What's the first thing you notice that's different about this problem than the last 2? There's a lot of numbers. Why are there a lot of numbers, though? I'm thinking you guys are saying it, but you're saying it awfully quiet. There's 3 circles, right? I heard somebody in the back say it. Remind me your name. Tyler. Okay. Tyler says there's 3 circles, and there are 3 circles because you see an A and a B and a C, right? So the first thing we're going to do is we're going to create our region, And we're going to draw the 3 circles. Let me make it a little bit tighter in. And your circles need to be big enough to actually accommodate the numbers, just like last time. But this time the numbers are going to have a different sort of a meaning than they did before. We're still going to list them A, B, C, okay? With you on the outside. Now, you have some pieces of information that you might be tempted to sort of go in order on, and you can't. And here's the deal. Right now, that first piece, it says the number of items in A is 24, right? The problem is I don't know where to put 24. And the reason I don't is because circle A right here is made up of 4 different spots. There's this outside here. There's this top piece. There's the 3 overlapping circles in the middle, and there's this bottom overlapping piece. And all 4 of those spaces have to add up to 24. And I don't know about you, but I don't want to just randomly guess and see if I'm right. That's a lot of guessing to add up to 4 numbers to give me 24. And the same problem happens again with the number of items in B and the number of items in C. So I'm not going to start with those 3 pieces. Now, the next piece is a little bit better. It says the number of items in A intersect B. Well, if I only take circles A and B, they intersect right here in this football shape. But there's still 2 areas where they intersect. And again, although I could do 10 into 2 areas better than 24 into 4 areas, I'm still going to be guessing if I start there. Make sense? Same thing for B intersects C and A intersects C. But the last piece of information is, well, almost the last. The next piece of information is extremely helpful. It talks about where A intersects B intersects C, and you know where that is. Where is it? The very middle. And there's only one place on the picture that does that, right? That's extremely helpful. So I'm actually going to start with that piece of information. That tells me that in the middle, there's a 6. And now what I'm going to do is I'm sort of going to work my way backwards with the list of information. All 3 of the pieces now that talked about 2 overlapping areas, I can find those because I know one of the 2 overlapping areas. It's 6. So I'm just going to go backwards on my list. I did this piece with the 6. I'm going to go back to A intersects C. So here's circle A and here's circle C. They interlap where the 6 is, and they overlap in this piece right here. What needs to go here so that these 2 add up to 15? 9. Right, we subtract the 15 minus the 6 and get 9. So now these 2 add to 15. There is no 15 written down on my chart though, right? There isn't, but the 2 pieces add to 15. Okay, we're going to go back one more. So we did this one. We're going to this one now. So this is B intersects C. Well, here's circle B, and here's circle C. And the 2 pieces where they overlap are these 2. I've already got 6 of them accounted for, and I need a total of 2 more to give me the 8, right? So there's going to be a 2 on the outside piece here. So we're sort of working our way on our diagram from the inside out. All right. Last overlapping piece is at the top, or at least on the top row. This one talks about A intersect B. So here's circle A and circle B, and these 2 pieces are the overlap. 6 of them are accounted for. How many are not? 4. This needs to be a 4, so these add to 10. So far, so good? Okay. That's really good because now when I go back and I look at any of the individual circles themselves, 3 of the pieces of the circle are already filled in. There's only 1 piece that's not. So we'll keep going with our pattern of working our way backwards with the list of information, and we'll talk about circle C. Circle C says there's 26 items in it, and this is circle C down here, right? How many are already accounted for? 17. 9 plus 6 is 15 plus 2 is 17. But there's supposed to be 26. How many are missing? 9. So I need 9 more down here in circle C for the whole circle to add to 26. Let's do the same thing with circle B. So circle B, I've got a 4, a 6, and a 2 in this piece. So how many do I already have accounted for?
12.
12. So how many are missing? 12. All right, now I've got circle A, also adds up to 24. I've got 4 and 6 and 9, which is 19. How many are missing? 5. And I'm almost done. What's missing? I haven't used this piece of information, and what do I need to use it to find? The outside of the circles. Exactly. So how am I going to do that?
Just 50.
Right. So we're going to subtract them from 50, and you probably would add them all up first. So you're going to add up all of these numbers. Okay. I know you can probably do it in your head. You can grab a calculator and do it in your calculator. It doesn't matter to me which one you do. What do they add up to on the inside? How many? I'm hearing lots of numbers, and none of them match. That's concerning. Should we add them together?
47.
47 is correct. They do add up to 47. All right, so you grab a calculator, or you write this down, or you count in your head. These circles all add up to 47. How many are missing? 3 to go on the outside. Okay, so we're building on what we've done. First example was looking at a picture and sort of figuring out which pieces matched up to what kind of a description. The second piece was this idea of using a formula, which you're going to see used a little bit in a minute here. And then this piece was taking this information and sort of fitting it into a description. The next example that we're looking at is a word problem. It has language. All right, so here's the pieces of information you're given. Joe writes and produces albums for musicians. Last year, he worked on 10 projects. He wrote and produced 2. He wrote 5. He produced 7. Okay, got in your picture in your mind what's going on? The directions say use a Venn diagram to work the problem out. So I've got space on my next slide. You've got space on your paper as well. All right, so the first question is how many circles do you need? 2, and 2's right. Why only 2 on this problem? Right. There's only 2 different things he's doing. He's writing, he's producing. And you can give those circles whatever names you'd like. I tend to actually name them what they are. That is to say, I would name the left-hand circle writing, and this one over here producing. You could call it W and P if you want to shorthand it. That would be fine. Okay, so something that shows you which piece is which. All right, so looking back at the information that we were given, we're told 2 things. 3 things. The first one, that he wrote and produced 2. The second one, that he wrote 5. And the third one, that he produced 7. Which piece of information is the piece I actually want to start with? The wrote and produced, right? Because the wrote and produced is actually an information that gives me what? What in this picture does it give me? The center. It gives me the overlap. And the key is that word and, right? And means intersection. Both of them happening at the same time. So that tells me I put a 2 in the middle. Okay? Next piece of information then, so I've taken care of the first piece, and it doesn't really matter now which piece I do next, so we'll just go in order. It says he wrote 5. So this whole circle over here is the ones that he wrote. So what's going to go on the outside part of the circle? 3, because the 3 and the 2 should add up to the 5 that I need, right? Yep. All right, the last piece of information was that he produced 7. So that's my right-hand circle. I have 2 in the middle. What needs to go on the outside? 5. I need to fill in one more piece of information, which is on the outside. How am I going to do that? Subtract these items from the total, which was 10. It says he wrote and produced, he worked on 10 of these anyways. So what goes on the outside of my rectangles? A 0. Okay. Yeah, it is nothing, but we're going to write the 0 in to show that we actually thought through the fact that it's supposed to be nothing. Okay. Remember, these numbers actually have a purpose behind them now, not just labeling an area. They actually mean how many items are in that area. And then we're going to take this the one step further now. Okay, so we turned this into language. That's new on this problem. The other thing on this problem that we need to do is we need to answer some questions based on this picture that we created. So question A says, how many projects did he write and not produce? 3. How many did he produce and not write? 5. And how many did he neither produce nor write? 0. Now, let me make one comment. These questions here should be based on your diagram. So if you screw up the diagram, but you answer all your questions based on your diagram, you still get credit for those items that you'd answered. Make sense? Okay, good. We have one last problem that we're going to look at. What is different about this problem? I have 3 circles. I do. There's a lot more going on, isn't there? So let's read through this together. At the University of Louisiana, half of the 48 mathematics majors receive federal financial aid in these ways. 5 have Pell Grants, 14 are in work study, 4 have TOPS scholarships, 2 have TOPS scholarships and are in work study, and those with Pell Grants have no other financial aid. Okay, so you have a picture of what's going on. Sort of, right? All right, we're going to draw then a diagram with 3 circles. What are my 3 circles? And I realize they're looking a lot like ovals. What are they? Pell Grants? Okay. Pell Grants, work study, and TOPS. And I'm going to do them in the order you told me. So this is Pell. This over here is work study. And down here is TOPS. Okay, everybody good with that? All right, so now let's go back to the information we're given and decide what is the most useful from the start. What piece of that information helps us the most? Okay, say again for me. The top scholarships and work study. Okay. If we look at the top scholarships and work study, there are 2 pieces right here that I have to look at, right? Not just one. So we need that piece before we have some of the others, but there might be one we want to look at first. Do you have an idea? That's really good information, isn't it? It says if you have a Pell Grant, you don't have anything else. Not only does that give you that the middle is 0, it gives you something else too, doesn't it? What else?
All the other overlapping circles will be
The ones that overlap with, oops, I wrote them in the wrong spots, that overlap with Pell. Was it Pell? That had nothing else? So these right here are zeros. Okay, those are really bad looking zeros, but yours are going to look much better. Those are all zeros because it says if you got a Pell Grant, apparently you didn't get anything else in this particular situation, right? That's actually really helpful for a couple of things. One of the things we could go back to is the one that Ethan mentioned, right? We could actually go back to now the work study TOPS where they overlap. So let's do that since he mentioned that one first. Work study and TOPS is how many? 2. So I can put a 2 in here now. What else can I do? All right, so I can subtract 2 from the college and then subtract 2 from the TOPS, right? So how many were having the college work study?
12.
Yeah, 14, and I've already taken care of 2 of them, so that'll be 12 on the top, exactly. And how many had TOPS total? Well, 4 had it total, right? And I already took care of 2, so there's 2 more down here in this bottom part with TOPS. What else? There's 2 pieces that I don't have in my picture yet. The Pell will be 5 because it said 5 people had Pell Grants, right? So I need those 5. What else do I need? I need something about on the outer side with the 48, right? All right, so let's take a look about what 48 was talking about. What was 48? Okay, so 48 is the math majors, and our diagram is representing having this work, or having federal aid. And it says half have federal aid, so what's half of 48? 24. So this picture I'm working with right now should not add up to 48. It should add up to 24. So I need a number inside the square rectangle here that will comprise the rest of the 24. How many do I have in my picture so far? 21. So how many am I missing? 3. Okay, everybody with me? Great. Problem number 1, or A, I guess. How many of the majors had no federal aid? 24, right? Half of them, because it said half had financial aid, the other half didn't. So 24 had no federal aid. They may have had other kinds of aid, just not federal aid. Are you guys clear on that? Because there's lots of other kinds of financial aid, just not federal aid in this particular problem. How many had more than one form of aid? Just 2 did, right? The 2 that's in the overlap right here. How many had federal aid other than the 3 forms listed? That's the 3 that's on the outside. How many had a TOPS scholarship or work study? 16. What do you have to add up when you have the word or? All the pieces of the circles. So I have 12 on the top, 2 in the overlap, and 2 in the bottom for the 16. Any questions on that one? All right.